Hello everyone and welcome to the Monday C# 101 and Introduction class. Today is the 5th week of the class. So we have today, we have next week, and that wraps up the 101 class. Awesome! Today, what we've got lined up was a look at enumerations, exception handling, and basic debugging. But Nelson and I did a little talking before class, and we decided to make today's class a little more interesting. So we're going to be adding in some basic file I/O today as well. So for those of you that do not know what I/O is, that's basic file input and output. So it should make the things that you can do with the applications that you create in C# much more interesting. So with that, Nelson, let's get jamming.
Okay, so I first want to go ahead and take a look at exception handling. So I'm going to go ahead and fire up a new console app. And so, yeah, we're going to talk about exception handling. And what is exception handling? Well, I'm sure most of you have probably already run into exceptions. For example, if I were to do int.parse ASDF, what's going to happen when I run this?
Well, yeah, don't everybody answer at once because we could actually jam up BuzzNet, you know.
So if I go ahead and hit F5, we will get this format exception was unhandled. And then we get a message, input string was not in the correct format. So what's happening is the int.parse method is looking at the input, ASDF, and realizing that it can't do anything useful with that input. And so what it does is it uses the standard form of error reporting in .NET called runtime exceptions to tell your code that it did something that it couldn't handle. More specifically, it's telling your code that it cannot perform its action given its inputs. It's impossible to convert ASDF into an integer. So what's happening here, I always had a question, why is this class 1 hour later today than before? Daylight savings time. Apparently, didn't it just hit for the UK?
Yep, Saturday night.
Yeah. So it's actually not 1 hour later.
Yeah, it's still on time for us.
You might want to set your clock back. Forward.
Forward. Yeah. Now we're back. Now we're back to the 6-hour difference. Okay, continue.
Okay, so what's going on here is the int.parse method cannot perform the action that you told it to perform. And the standard mechanism in .NET for reporting those errors is through exceptions. Exceptions will, by default, halt your program unless they're handled. You'll notice up here it says format exception was unhandled. What that means is we can actually handle that exception and perform our own useful logic given an error condition to keep our program running. Because obviously in quite a few scenarios we don't want our exceptions to crash our program, generally speaking. So there is a bit of syntax you can use to capture an exception and perform alternate logic if an error was encountered during executing your program. And that's going to be the try block, followed for now. We are going to be talking about something else you can do, but followed for now by the catch block. Now,
let's get them to type this stuff out, man. Let's get them involved. Type it.
Type it. I just reset all of you people, so type it.
And a quick question for those that have already knocked this out. So, Wendy, awesome. Taking notes tonight. That's fantastic. I love those that take notes when they watch it through the first time, then they go back through the second time with it in the video system with their notes, watch it again, and try to follow along. It just really makes the content solidify much more in your head. Is the video system working better for you guys? Because at this point, we can't get anything to mess up, both here and at Nelson's. Okay, good deal. Thanks, guys. Thank you for bearing with us. Last video seems to be a little out of sync. I'll check it again. I checked it when I encoded it to put up, and it was running in sync with me. But I'll look at it again for you. All right, about 1 hour in. Okay, I'll check that. But good, I'm glad to see that it seems to be running much better for everyone, because we can't produce any troubles whatsoever over here. It just really went downhill quick once we put Zach's half a gig Blender file in there. The whole system was just like, boom. We won't be doing that again, though. All right, so remember, if you are participating, this isn't much code to type out. Please make sure to hit the little I'm ready button. All right, there we come. A couple new participants just jumped in and jumped out. There, it's looking good. Come on, you can do it. Come on. Come on, Barry. All right. All right, for those of you that are still typing this out, hit the 1 more minute button. So I know we have no AFKers.
Looks like
we might have some AFKers. Okay, let's go ahead and continue then.
Okay, so this code is basically going to do something very interesting. So I'm going to go ahead and say Console.Writeline 2 and Console.Writeline 1. And then at the end of the try catch, I'm going to say console read key. So go ahead and type that out. I just added 3 more lines. Console.Writeline 1 after the int.parse, that's important. Console.Writeline 2, and then console.read key.
Ooh, Nelson. While they're typing the little couple lines in, we're gonna add one more thing into today as well. We must make today an epic class. Guess what I'm gonna put in today?
Generics.
Oh, how'd you know? String.Format. String.Format.
Oh yeah, we could do that.
Yeah. No, damnation, what's wrong with you? The correct answer is yes. Yes, generics are better, but we did a whole free class on generics. Or wait, did we? No,
it was on Delegates.
It was on Delegates. Whoopsie.
What about single line blocks? Just to make Nelson really happy.
You mean combining link, string.format, string.join, and
string? No, I didn't. I was being serious. I meant if one line of code for one line of code. With no.
Yeah. We can. I guess we can.
No, no. Let's just stick. Let's keep it simple, because we've already got all the I/O stuff in today. So with file I/O and string.format, today shall be epic.
Okay, so when I run this program, guess what we're going to see?
So leave that up and just use your mouse to point and kind of walk through it.
Okay, so the try block, what that's going to do is it's going to think of it like a buffer for exceptions. If an exception is thrown while executing the try block, that exception is going to halt execution of the try block and then continue on the first matching catch, if possible. Now, in this case, what we have is called the generic or general catch clause, which means this catch block will capture any error that could possibly happen. If we were to run out of memory right here, we would get an exception. This catch block would execute, for example, and so on.
So go ahead and close down the console. And we had a request over in the questions panel about you making your font just a little bit larger.
I already did.
Oh, I was looking at BuzzNet then when you did it. Sweet. Okay. And then we also have, Jen had a question for you.
My catch line automatically added the exception argument and throw line after. Do we need this? That could have been from ReSharper, or could have been if you had done that. we're going to explain that syntax that shows up with the template. But for now, we're just worrying about the general catch block. We'll go into what else can go in here very shortly. Okay, so what's happened? So like I said, when we enter a try block, we're going to capture any exception that happens during the execution of the try block. When an exception does happen, it's going to halt execution of the try block and find the first matching catch. This catch syntax will catch every single exception that runs through it. However, if you recall, the int.parse method actually will throw something called a format exception if it was an error. And so this does bring up a really quick, we're going to be talking about this a little bit more, but this does bring up a very interesting discussion about exception handling design. Now, there are a variety of kinds of exceptions or logical groups of exceptions that might be thrown. There are going to be exceptions that were caused by user input. There are going to be exceptions that are caused by bugs in your code. And there are going to be exceptions caused by things that you cannot really change. Exceptions that are caused by bugs in your code, such as a null reference exception or an index out of range exception. Like, for example, if we had code like this, this is a bug. If I were to run this code, we would get a nice little exception, an index out of range exception. But this is a bug, meaning that this is a logical error in your program that should be fixed. You should be notified of this problem and you should correct it. This is not the kind of exception that you want to catch at all. I want to point that out. Do not, because now we've introduced a way to capture all the exceptions that could be thrown by your program. You have to be very careful with this because you don't want to hide a bug from yourself, ever.
Like JT just said over in the BuzzNet, wrap an entire program in try catch. Exactly.
Yeah, that would be automatic fail. Well, if you rethrow the exception after that, if you're doing it for logging purposes, then that's fine. But I'll get into that later.
Right. But for now, no, you would not want to do something like that.
Nope.
I know you were kidding, but it is good to point out in case somebody else was thinking, oh, I could just put everything that's in main in a try catch.
Yeah, and the purpose is you do not want to hide exceptions from yourself because exceptions are the most common way that you'll be notified of bugs in your program. And if you hide them, if you eat them, then you will never find bugs in your program. So don't do that. Which means the particular the utility of the general catch block, it does have a purpose, but for now we're going to just say that this isn't something you would ever really want to do. Instead, what you want to do is you want to inform the C# compiler that you want to capture a specific exception. Now, in this case, there is a try parse method that we would be using instead of int.parse in this case, because int.tryparse is more correct when dealing with user input. Wait a second, are people losing sound?
Just two. Everybody else kept on hearing fine. It just comes down to where people are at, hops, if there's router problems. It's nothing that we can control whatsoever.
Okay. So in this case, let's imagine that this line of code is doing something that we can in no way guarantee will correctly work. Again, this is not a great example, but the only real example I can use given what we've already taught. And the reason it's not a great example is that you would want to use int.tryparse instead of this code, which brings up another design discussion about exceptions that I'll talk about in a second. Just to be sure, try to compile try, and if there's an error, it'll go to catch. Oh, that's a good question. It's not. A try will not allow you to compile invalid code. If I were to put a syntax error in here, such as int 120, for example, this is a syntax error, the code still does not compile. The try catch is for runtime exceptions. Exceptions are the runtime way or the standardized way to let your program know that something happened that made it impossible for your program to continue executing. Or more specifically, something happened that made a particular method it made that method not capable of continuing to execute. So if you have some code that you know there's a potential for an exception being thrown, and you have a backup plan, that's another condition. You know that you want alternative behavior if this particular thing fails. If you do not know that you have particular alternative behavior when something very particular fails, then you shouldn't be using exception handling in the first place. But if you do, what you can do is inside of the parentheses after the catch block. So you see that this is a general catch block. We can add parentheses. And inside the parentheses, we can place a type. So for example, if I were to go ahead and do this, completely 100% valid C# code, what will the output be? Any guesses about what the output of this program is going to be?
How is that valid?
What should the output be now? Or actually, that's a bad example. Derp. So now if I run this program, we see an index out of bounds exception was unhandled. And the reason the index out of range exception wasn't handled was because we only have a catch block for the format exception.
Yeah, as Segfault just said, no handler.
Yep, there is no handler for this particular exception. Now, I do want to point out something we can do. We can put as many catch blocks as we want. We could say catch index out of range exception. Again, you wouldn't want to do this in your code necessarily, but you could. I mean, there are a lot of cases where catching multiple exceptions is a good thing, but in this particular example, we're eating a bug, and you shouldn't eat bugs.
But if you were to do that, is there any way then of making it go back and doing the int.parse and Console.Writeline?
No, there's no way.
Other than putting them in the catch as well?
Nope. It's impossible to execute the code in a try block after an exception was thrown. Okay, so is everybody good so far with what is being shown? Any specific questions about exceptions? Because I am going to bring up two more things here. That's very important. A variety of times, can you do an empty catch block too? Yes. I could do this if I wanted to. I could also do this. Actually, this might throw an error because it's redundant. Oh, no, it's going to let me do it. It's going to warn me, though. I can also do this, and I can do this in addition. So I can make as many catch blocks as I want. Now, what this catch block is doing actually is the exact same as this catch block, which is why the C# compiler is warning me about it. And the reason why this catch block is the same as the general catch block is because it catches every exception. We haven't talked about inheritance yet, but you can think about exceptions in a hierarchy. And every exception at the root level is an exception type. And every other exception is a specific type underneath that exception type. If we were to catch an exception, we would catch everything, which would have the exact same behavior as this general catch block. Yes, I do want to point out that, like for example, doing this, While we are using exceptions correctly in that we are catching something that could happen that we could avoid it in this case, but we're pretending that we can avoid it. The fact that int.parse throws an exception. We are using this correctly because we are catching something that might happen outside of our control, and we have alternate behavior to perform. But because int.parse does have a corresponding int.tryparse method, always prefer the tryparse method. And the reasoning behind that is that exceptions should not be used for flow control. Exceptions are not a way to replace an if statement or a while statement or something like that. Exceptions should be exceptional.
And Nelson, real quick, like Jen just pointed out over in BuzzNet, please make sure to read the question too, because when you just suddenly get excited and say yes and start talking, they don't know exactly what you're talking about.
The question was, should I use tryparse and similar like above try-catch statements? To handle exceptional cases, to handle cases...
Read the question.
Then when should we use it? To handle exceptional cases, to handle cases where we know that something potentially bad can happen, and there's not much we can do to avoid it. For example, file input and output, there are cases where, we could say if file exists, then append to file, but between those two lines, that file could be deleted, for example. An exception would be thrown. And there's really not many ways without getting very technical into locking of files and stuff to actually get that behavior to 100% guarantee you are going to actually perform something correct. So in that case, you would have a try-catch, and your catch handler might simply retry the operation or create the file if it wasn't already created, and so on. You would use exception handling when dealing with like network streams, where if the connection is lost, something completely out of your control, if the connection is lost and an exception is thrown, you want to handle that exception and try to reconnect as best you can. And then if you can't reconnect, then you go ahead and blow up. Okay, so any more questions?
Remember,
okay.
to guarantee that we answer questions that you may have, make sure to put them in the questions panel. If you put them in BuzzNet, you can get help from, people like SegFault and all, but it's no guarantee that we're going to see those.
Wolf says, I don't understand why it would be bad to catch an exception. The biggest problem with catching exception is eating bugs.
What if you were going back to your add example from the previous class, if you were expecting user input of 2 integers and you caught that but just buried it somehow, the exception, and then your program carried on trying to add, you have no way of knowing what it's trying to add, or
like a division of 0, for example. Yeah. Or something like that, something that if you wrap your entire program in a general catch clause or a catch clause with a specific exception and do not rethrow it, which is something we're going to be talking about in a second, then, yeah, that's not good because you'll be eating exceptions. Actually, it was funny, BuzzNet, as I was developing or working on BuzzNet, still under heavy development, obviously, I use a library called SignalR to handle the real-time communication between all the clients. Very cool library. It handles all the long polling for me, so everybody gets a very nice real-time experience. Well, I was having some issues with people disconnecting. My code never got fired. And I sat there and I looked at it, and I had no idea why that was happening. I read through the documentation. I looked everywhere on the internet. I had no idea why SignalR was not telling my code that a client disconnected. Well, I finally just throw my hands up, grab the source code, because SignalR is open source, compile my own version of it based off the source code, load it into my application, fire up the debugger, and walk through every single line of code that happens in SignalR as a client disconnects. Well, it turns out that a piece of my code that I completely forgot about was being invoked and throwing an exception. and that was completely short-circuiting the entire, like, it even has a comment in it that says, I can't remember I wish I can remember what the comment is, but I looked at that general catch and I said, you know what, code, you just wasted, 5 hours of my life, because I was never made aware that there's an exception being thrown at all. So catching general exceptions and not notifying somebody is a bad thing. And I can show you what that looks like if, I can't remember exactly what file it is, but I think the file might be already open once Visual Studio decides to stop being slow. Nah, it looks like I closed the file, unfortunately. But it was very, very, very frustrating that SignalR decided that it was going to eat my exception because I had no idea where my bug was. And it was a very, very frustrating experience. But can't you check for things in the handled exception? I don't know what you mean by that. I mean, I can go over some things you can do with exception handling that makes it a little bit more powerful, and I was going to do that here in a second. So maybe if you re-ask your question after I go over a few more things. Okay, so we've talked about how to catch specific exceptions, and we've talked about this particular case. However, this particular type of exception handler is very useful, even though you wouldn't want to use it in its current form. It's useful for logging purposes. For example, if you have a program or you have a piece of code that you know is going to throw or has a potential to throw, and you want to notify the user in some very specific way that something happened, or more specifically, you want to log that exception out into a file, what you can do is actually capture the exception variable. Now, exception variables are actual full objects that are given to you by whoever threw the exception. And by giving an identifier to this type, we have created a variable that we can then reference. We could say, for example, Console.Writeline e.message. Now, if we run this, instead of the program crashing, we now get index was outside the bounds of the array. Now, this is still technically bad practice. We definitely don't want to display error messages to the user or exceptions to the user unless unless you have a very specific exception type that's specifically made for showing user something. And also, we're still eating it, meaning our program isn't dying in any way or indicating anywhere other than the console that a problem had occurred. So now that we've performed some basic logging here, so we can say log message to file or network stream or something. There is a way for us to catch an exception, perform an operation based off what the exception contains, and then throw it again. Meaning we'll catch it, we'll do something, and then we'll say, okay, we're done doing our stuff. Here, have an exception to everybody above it. So what I can do is I can say throw E. This line of code right here will still cause the exception to be thrown, but as you saw a second ago, the logic that we wanted to perform was still performed. So we kind of get the best of both worlds. We get to capture all the exceptions and perform some sort of logging operation, which is good, but we also throw the exception back into the program so that we get notified as a developer that something really bad happened.
And Nelson, I just want to make sure that you see this real quick because Mike's pointed it out over in BuzzNet, and he also did over in the question panel. He's running the latest version of IE, but apparently he's tried a few other browsers as well. It says BuzzNet stops working for me every 2 to 3 minutes, no matter which browser I'm using.
That's weird. I wonder if it's a...
Yeah, I don't know, because it's running great for me.
Could you send us at some point your internet connection speed and if you're over Wi-Fi or not? Okay, well, yeah, hopefully we can figure this out at some point.
Yeah. Okay, so continuing.
We got a question about finally. We're going to be going over finallys. Okay, so what we have done here is we've captured the exception, performed some logic, and then read through it. There's an alternate syntax here. We could say throw E, or we can just say throw semi. And throw semi will simply throw this syntax is only valid within catch blocks, and it'll simply rethrow the exception. Okay, so is everybody good so far with exceptions? I know that there are some design considerations that we've been talking about, and of course those things will become more apparent the more time you work with programming. The biggest design thing to know, though, or the two biggest things, is exception handling is not for conditionals, or they're not a replacement for ifs, and they are not, you should never have an empty catch block that doesn't rethrow the exception in your program,
And
unless in very specific cases.
And Ray's got a question for you in the questions panel.
When you say rethrow the exception, what is a rethrow? A rethrow is what I have here on line 25. I catch the exception, I alias it into a variable I can use, and then I perform an operation using that exception variable. For example, log it to somewhere, and then I rethrow it. And this throw statement, which is synonymous with this, both of these lines are completely equivalent. What it's going to do is it's going to take this exception and throw it again.
Meaning the program will crash then.
Yes, the program will crash.
So the catch actually catches the exception and the program does not crash. What if you wanted to write that information out to a log that you were then going to send back to whoever developed your application? But of course, you don't want execution of the program to continue because something bad just went down. So this way, it gives you an opportunity to jump in there and grab exactly what went wrong, write it to a log file, and then let the program finish crashing.
Okay. So I do want to point, okay, so now we've talked about that a little bit. I do want to talk just really quickly. Well, I mean, we can go back to call stacks once we start talking about the debugger. I think that might make a little bit more sense, Jason. What do you think?
Yeah, I do.
Okay, so we won't talk about that for now.
But take a look at what just came in from Enrico.
So the lesson to take from try-catch sessions is to use try followed by specific catches, and at the end a default catch all statement with each and every one of those catch statements using throw. No. If you catch a specific exception, such as format exception, for example, again, when I'm using int.parse in this example, we are pretending that int.tryparse doesn't exist. But what you might want to do is something like this. You could say, while true, try, or we can say int result, try result equals int.parse Console.Writeline catch format exception Console.Writeline invalid input. If int.tryparse physically did not exist, this would be a valid use case for try catch, for example. And what makes this valid is that we are catching a specific exception, and that exception is something that we cannot know ahead of time how to fix. Now, if we have a bug such as this right here, that sometimes our index were accessed out of range, at that point we should really fix the bug that is causing that exception to be thrown in the first place.
Instead of hiding it.
Instead of hiding it. But in this case, because the input or the whether or not the exception is going to be thrown is predicated on user input, we can't know ahead of time if this code is going to throw or not.
So
what we
go
do
ahead
is
and
we wrap it in.
throw a break in there to demonstrate how.
Right. This break will correspond to this while.
And now you can kill out or comment out from line 27 on down, all of that, and then you can just put out some, put a console. Yeah, there you go. And a read key.
So in this case, I can put in a bunch of invalid input, but if I put in a valid input, I get the proper result. So what makes this a valid use of try-catch, again, is that we cannot know ahead of time if this will fail. We have a specific exception that we are catching, and we have a specific behavior that we are going to invoke when this error happens. The specific behavior isn't entirely obvious here because we are inside of a while loop, but if I were to explain the specific behavior in English, I would say if the user inputted something incorrect, we get a format exception. Then inform the user that they have typed in invalid input, and then ask them for the input again. So that's the behavior we want to execute for this specific error. If something else bad happened inside of this, such as an index out of range exception or another bug, we do not want that to be caught. We want that to bubble up and throw and inform the developer that their program crashed. So NATO says it's a bit like an if-else for when things go bad. It kind of. I mean, what you said is correct, but remember that exception handling and throwing exceptions should not be used in place of if and else's. Exceptions, as particularly throwing your own exceptions, which we're going to be talking about throwing your own exceptions later once we start talking about the call stack, but throwing your exceptions, you should only ever throw an exception when something happens that makes it so your code cannot properly continue to execute. So throw is used mostly on logical bugs and not user inputs, like file missing. I'm trying to understand how to use try-catch throw with good design. It's throwing an exception and catching exceptions should only happen when you're in a situation that your program cannot control. There's a variety of things that your program cannot control. They cannot control the user's competence. They cannot control your internet connection. They cannot control your hard drive being plugged in at the moment it tries to write a file. It cannot control your graphics driver not being reset after drawing the last frame. It cannot control a lot of different things. And there are a lot of those things that your program can never control. Therefore, you can never guarantee 100% logically that these things will never happen. But you still have valid logic that you could execute in place of your program failing. For example, let's say your video card driver or your video card reset between frames. And what I mean by that is all the memory inside of your video card has been erased. So all of the meshes and textures you loaded are no longer available. So you don't want your program to die when that happens because A, you can't control that happening or not. You can't write a program that won't cause your video card to fail, period. But you do have a valid set of operations to perform to correct that error if it happens. Simply reload and everything into memory, into video memory. So what you could do is you could put a try catch on your, above your update method. You can say catch a specific exception relating to your video card being reset. And then you could say, if that happens, simply reload all our assets and keep on going. So it's all about whether or not your program, A, is catching something out of its control, and B, has valid code to perform in place of crashing. Can I create my own exception types? You can. Can you catch multiple exceptions in the try block, or does it stop on the first exception? It stops on the first exception. If this line were to fail, none of these lines would execute. It would simply, that exception would be bubbled up even within the int.parse method itself. When that exception is thrown, no other code is executed until you unravel the stack, which we're going to be talking about later when we get into debugging, and find a valid try-catch block or a valid catch block that is capable of handling that particular exception. So throw from the program's point of view means I throw up. Pretty much. It's done. It can't do anything more. It physically can't execute a piece of code, and it can't logically continue. So it just throws, and it's done until somebody catches it, or nobody catches it, and your program just crashes. Okay, so why would you use that instead of an if statement? You wouldn't use exception handling instead of an if statement, ever. Exception handling, again, is for exceptional cases that are outside of your program's control, which people here are going to be starting to see a lot of, because once we start getting into file I/O is the first bit that we've discussed in that class that can actually fail in a way that's outside of the developer's control. Because a person can physically disconnect their hard drive while your program is running. Well, then the operating system would probably crash. But you get what I mean. Maybe the sector that your program was writing to was in some way corrupt or something like that. In that case, if you wanted to handle those cases, you could using exception handling. Okay, is everybody good so far? It's a good practice to cover your code and try catches to cover everything you could think could ever break, such as hard drive error, out of memory, graphics failure, etc. You shouldn't do that unless you have a very specific piece of code that you want to execute, given that particular error condition. Out of memory in particular, I would just let my program die. If I had a video game, if I was building a video game that used your 3D graphic accelerator, I would handle a case that my video card got reset, just because that's common. Specifically, the device, the DirectX device object, for example, gets unloaded and reloaded when you minimize your window, for example. And so you really do need, because that error condition is so common, you'll really need to handle that very well. Makes me want to go clean old C++ program I made, use try-catch instead of try-parse. C++ exception handling is very funky, not consistent, and gross. But in C# they really got exception handling right. Okay, so is everybody good? Is everybody good? Because there's one more thing we really want to talk about with try-catches here.
Yeah, let's go ahead and do it.
Okay. Okay, everybody, write this code out and tell me what you think the output is without hitting F5. That'd be cheating. Okay. Looks like most people guessed 2 and 3, but I want to do something more here. Okay, now what's the output of this program? Any guesses? We got a few of the same. We got some 2, 3, 4s. We got some 2, 3, 4, 5, 6s. 2, 3, 4, 6 seems to be the most common guess. We got a 3 and a 6. Two, 3, 4, 6. Now the reason we're getting 2, 3, 4, 6. So let's go ahead and just walk through this program really quickly. What happens on line 14 is line 14 is the first line of executable code. And what's going to happen is int.parse is going to throw an exception. 15 will never execute because an exception was thrown. Instead, execution will go onto 19 because this catch block is capable of handling any exception that's thrown. So we get 2 written out to the screen. But then something else happens here. This finally block is very, very, very important and useful. A finally block will execute whether or not an exception was thrown. It will always execute. It'll even execute if we returned out of the method, which we'll talk about in a second. So the finally block is a very cool little piece of syntax that will always execute no matter what. So the result we get up until this point is going to be 2 followed by 3. Now the next line of executable code is on line 28. This line does not throw an exception. Console.Writeline 4 will not throw an exception. So we'll get 4 written out to the screen. You'll see that 4 right there. Because no exception was thrown, line 32 never executes. So we never get a 5 written out to the screen. But remember, finally blocks always execute. They will always execute for any reason. So line 36 follows, and we get 6. So we get 2, 3, 4, and 6. So finally blocks, very cool piece of syntax. They will always execute. Now I want to bring up something cool here. A try block on its own is not valid syntax. A try block with a catch is valid syntax. A try block with multiple catches is valid. A try block with a catch and a finally is valid. And a try block with just a finally is valid. So here's, and of course, we could also have a try block with multiple catches followed by a finally. So here are the combinations that we can use. We can use, again, a try and a catch, a try with multiple catches, a try with a catch and a finally, a try and a finally, and a try and multiple catches and a finally. Somebody just asked, a try with just a finally would have what type of use? Very, very good question. And I think I'm going to answer that.
Well, that's awfully kind of you, sir.
The first use of a try and a finally would be to execute code given that your program had, or given that your method had returned. Wish I could make this a little bit more interesting. Okay. We did have a question. Let me see. You may have covered it, but does it finally execute if you rethrow instead of a catch? It does. Finally will always execute. Can you have a try block inside of a try block? Yes. But I want to hold off showing an example of that until we get to call stacks. So here's the first scenario that a try and a finally is incredibly useful. Now everybody remembers what return does, right? All right, everyone. What is the output of this program? Oh, that was a bad example. No, yeah, that was a bad example. Ignore me. 10. Let me see. Okay. Now what's the output of this program? I just changed the numbers around. I realized that I had some really stupid logic in there, which this logic is pretty stupid still, but it's a little bit less stupid. All right, so we got some 12 cleanup, 4 cleanup, 1 cleanups, some 12 4 1s, and we got 12 cleanup, 1 cleanup. Another 12 4 1. Ooh, a 12 4 1 cleanup. All right, so quite a few different answers. Watch this.
It's the work of the devil, sir.
Nobody, Segfault didn't even get this one.
I noticed.
Come on, Segfault.
And he's, of course, going to fall back immediately on, oops, I misread.
Okay, so finally is run before the try? No, actually, I think that's a good question right there. We got a question. So finally is run before the try because you see this Console.Writeline cleanup happens before the output. Think very carefully about how this Console.Writeline is working. This Console.Writeline is only going to be invoked after my method is invoked. So if I were to, at the beginning of the try block, say Console.Writeline begin method, you would see begin method and then cleanup and then 12. Because when line 12 executes, my method is invoked with the parameter or the argument of 10. It'll enter line 23, which will say Console.Writeline begin method. It'll then return a value, and then it will collect the value to be returned, and then it'll execute the cleanup method or write line on line 38. Then once it has the value of either 1, 12, or 4, then the Console.Writeline executes. So this is a very, very valid use of try-catch or try-finallys. That actually it's so useful that the C# language the developers of the C# language invented a shorthand for this that we'll be discussing later once we get into file I/O. In fact, this try and finally is why we're discussing try and catch before file I/O.
And Enrico asks over in the in BuzzNet, so finally executes directly after the return? No.
No. Well, The return will signal that finally will execute, but the method won't exit until the finally is run.
Correct. And then we're returned back with the data that's being sent back. And it's not until the data is sent back that lines 12 through 14 will have an opportunity to actually write out what comes back.
Yeah, I can go ahead
Return.
You what?
I was going to say return acts a lot more like a courier service than a post box. It picks up the value to return, but the finally actually gets to happen before it goes off and delivers its return.
Yep.
I think what Nelson just typed up in the example is really good when he runs this.
So the first thing is begin method, returning 12, then cleanup. Then we get 12 because of what happens here on line 12, because the Console.Writeline is then executing itself or being invoked with the argument of whatever was returned from my method. Then we have another begin method, returning 4, which you'll see right down here, cleanup, which is the finally again, and then finally on line 13, that write line gets invoked, and we get the result of 4. Then we get begin method returning 1 and cleanup 1.
Hey,
Can finally read what. You what?
I was about to point that out to you.
Yeah. No, the finally has no way to access the return value. Finally can be used for freeing up unmanaged resources. Yes, and we'll be talking about that once we talk about streams. Okay, so that's one of the uses of finally that you will use a lot, where you want to execute some cleanup code, whether or not an exception was thrown or return was invoked or sent. Like, for example, what if we did this? Okay, now this is going to be a little bit more complicated, but what do you guys think the output of this will be? Actually, yeah. Any guesses? It's a little bit more complicated, but... Okay, so if I go ahead and run this, now we do get an exception, of course. Well, actually, a better example would be to wrap this in a try catch. Okay, so this should make it a little bit more straightforward. Begin method, again, so remember, we're on line 14. Returning 12 on line 38, and then cleanup. Then we print out 12. Then we enter line 15, where we invoke my method 2, and we get begin method. But here's where things go crazy. We get begin method, but then immediately after we get cleanup. And we don't get anything else out of this try log. Florum finally will always get hit. It'll get hit whether you return out of the method. It'll get, if you don't return out of the method, it'll get hit when you throw an exception. It'll get hit when you don't throw an exception.
So basically, it will be hit no matter what. If try completely succeeds, it'll still be hit. And if we end up having to catch an exception, it'll still be hit. Yeah, we're about to go on break in just a minute here. Are there any more questions about this?
What if you hit an infinite loop and somebody unplugs your PC? If you can find a way to put a try-catch around somebody unplugging your computer, I will give you $100.
Have a backup system, tie it into a relay with a voltage generator, and
No, well,
put a metal plate, and when they unplug it, they get electrocuted. But the computer keeps running. I'm just saying, yeah, with the ups.
Yeah, ups and some guns.
Is finally good for logging. I mean, if you wanted to. Remember that a finally is not going to know if you threw or not. What would be a good use for a finally block? Any sort of cleanup that you want to perform regardless if your method executed properly. For example, Segfault threw out the word a little while ago called an unmanaged resource. Now in C#, we have been using a bunch of managed resources. We've been using managed memory that automatically gets cleaned up when it's no longer in use. However, there are situations where you need to use an unmanaged resource, meaning you need to go ask somebody to give you a resource, such as a stream into a file, a stream into the network, a database connection, and all those things are going to be unmanaged resources that you have to deterministically close when you're finished with them. You want to close those resources whether or not your program successfully executed or not, whether or not your method successfully executed. You always want to clean up those resources. So you always want to wrap cleanup of resources in a finally block. So is everybody good?
All right, so if you have any questions over the break, just go ahead and throw those into the questions panel. But now is a good time for us to go ahead and take about a 10-minute break, and we will just catch you guys back here in about 10 minutes. So I'm going to go ahead and pause the video. Okay, and we're back from break, so let's go ahead and continue.
Okay, so we had questions, and one of the questions that came in was, can you have a finally on its own? And the answer is no. A finally on its own does nothing. You must have a try block immediately preceding the finally block. Okay, so so finally is for cleanup, throw is for own baggy code, catch are for handling external bugs or incidents. Sounds about right, yeah.
Okay, so anything else?
Are there any questions?
Yeah, they had enough time to come up with questions during the break. Let's get to it.
So, what do you think's next?
That we should do next?
Yeah.
Yeah, let's go ahead and show string format.
Okay.
Because we can start mixing all of these things together, which is awesome. Oh, be quiet, done. Ugh, pizza sounds so good right now.
Okay. So there's two ways that I can print out this data. Well, there's three ways, and we're going to be talking about one way, then we're going to talk about the... Okay, so code. Okay. Is everybody good with what this code prints out? If there's any questions about what this code is doing, then...
Yeah, this should be super simple stuff.
Any guesses as to what this prints out? Any guesses as to what that prints out? Oh, we did get an error. As far as the guesses go, not as far as the code goes.
An error.
I really want to make sure that you guys understand this today because we're going to start using it a lot.
So we now have two alternate ways to print out data to the console. What we have here is string formatting. String.Format is a method that takes in a string followed by an array of objects, and that array of objects uses what's called the params modifier, meaning that we can supply as many arguments as we want to the string.format method. Now, string.format, remember, does return a string, so we could do this. So this is one way to, this is how you would get a string format out into a variable for any other purpose and then print it out. However, Console.Writeline also does have an overload that takes in a string format or format string. So you can use Console.Writeline directly with format strings without having to use the string.format method. However, their behavior is the exact same. The only difference is that this Console.Writeline invocation will simply defer to the string.format method when it executes.
So let's go ahead and pause for a second and let our absolute beginners type this out. You going to reset your...
Yeah. Maybe.
Not today.
Okay, so that should be reset.
And yes, Barry, you do have to use the open and closing curly braces, and we'll talk about the templates or the placeholders in just a minute.
How does it know the type parameters passed in the last example? It does not. In fact, the type parameters that you pass in is completely irrelevant because string.format will simply invoke the toString method on any of the arguments you pass in.
So if you're copying this real quick, just try clicking on the 1 more minute button. Yeah, that's working for me. Thank you very much, guys. This is a really good example to have.
But still does need to know beforehand the type of a function call, or does it accept all objects? If you look at the signature, you'll see that it indeed does accept anything that is an object, which is everything. You will notice that there are some overloads on string.format. For example, here's one that takes in 1 argument. Here's one that takes in, okay, it only has one that takes in 1 and then one that takes in many. I think string.format, yeah, there we go. The Console.Writeline has an overload that takes in an arbitrary amount of arguments, but it also has overloads that take in a bunch of arguments. These do the exact same thing. The reason that there are both of them is for compatibility with previous versions of .NET that didn't have the params modifier. It does take it in as an array, but it uses something called the params modifier, which I don't know if Jason wants to talk about.
No,
that.
not at this point. Yes, they are cool, SecVault, and so are generics, lambdas, delegates, link. Just listen to Wolfery. He got it. Short answer, yes. Long answer, kind of yes.
Yeah, I'm with Florum. I don't trust delegates.
You don't trust them?
I use them now. Well, I use them. I think what I don't trust is my ability to understand what I'm doing. I use them and they work. But how much of that is me and how much of that is intelligence is debatable.
Well, delegates are funky because whenever you do use a delegate, you could always refactor that code to use, either a base class or an interface instead. So it becomes a design discussion when you talk about whether or not to use an interface or a base type or a delegate. And
just for the record, real quick, everyone just finished. So if we want to start explaining about the placeholders and all. Okay. So again, this format right here is going to be the same here. It's just that somebody posted in the answers, is this overload going to simply defer to String.Format? And yes. The syntax Console.Writeline simply has an overload that allows us to use a format string or a string format instead of having to call it directly. But you would still need to use String.Format in cases where you just want to return a string and do some more processing with it instead of just writing out to console. You'll see a lot of instances of methods from other libraries, such as logging libraries, that do take in or do have methods called stuff like debug format that also take in format strings. So this syntax is actually a standard in the .NET framework. And what it is it's a way to describe how to output a group of objects in particular ways. So what happens here is this 0 or anything encased inside of these curly braces is going to be an index relating to the object that was passed into the array. So name and age are both passed in as an array, technically. It doesn't look like you're passing it as an array, but you actually are, just behind the scenes. And so think about these two arguments as items in an array. So name is at index 0, age is at index 1. So we have our placeholders that allow us to refer or reference our objects. I could swap these if I wanted to. I could say print 1 first, then print 0. And I'll say my name is 1024 and my age is Nelson. Or I could repeatedly use this same placeholder over and over and over again as many times as I want. So my name is 1024 and my age is Nelson, 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 Nelson. So these placeholders simply allow you to reference the objects that you pass in. I do want to point out, though, that if I were to, for example, say my age is at index 2, I will get, I should have actually asked people, but I get a format exception. Index 0 base must be greater or equal to 0 and less than the size of the argument list. So you will get an exception if you try to index an item that is outside of the bounds of the array. Unfortunately, this is a runtime exception. There's no way for the compiler to determine if this is valid before it runs. So you will get a nice little runtime exception if this happens.
Can I ask you a quick question? I don't want to drag it too much off topic, but why does that throw a format exception, not an argument, an index out of range exception?
Honestly, I would rather it throw an argument index out of range exception, but it's throwing a format exception instead.
Okay.
And this is something that they can't change because of existing code that might be specifically catching this exception. So there's a lot of cases where previous design decisions were incorrect, but they're simply not able to fix it in later versions of .NET. Okay, so this is the most basic usage of string formats or string formatting in .NET. Are there any questions about this specifically? I do want to point out that this is not an exception you want to catch, because this means your code is wrong. And if your code is wrong, you do not want to catch that exception. Furthermore, if this array was passed in by the user, you would want to validate that its length is correct before sending it to String.Format in the first place. Okay, does anybody have, okay, so what if you wanted to print 0 and also have the first arg? What if you wanted to print 0? Oh, good question. The escape sequence for this syntax is going to be double curlies. So my 0 is Nelson and my age is 102 far. Did that answer your question? Okay. So is everybody good? Is everybody good? Because there are some more cool things we can do with String.Format. I'm not going to go over very many of them, but I do want to make you people aware of some of the fun stuff we can do.
Yeah, I'd not go too deep.
Are you going to cover argument padding?
Yeah.
Cool.
Okay, so I guess there's no questions. Let's go ahead and, so first of all, everybody's good that you can use the String.Format method if you wanted just to return the string, because from here on out, I think I'm just going to be using the Console.Writeline overload. But I want to just make sure that everybody's good with that String.Format will allow you to alias out the result of this into a variable. If you have the third variable in there, will you get an error? So if you have something like that, for example, no. That is valid. It's just ignored. In fact, I could say, I could completely ignore, I can just say my name is 0 and ignore the other two arguments. Okay, so let's say we wanted to print out to, I think that's good. Good. Okay. Creepy counting.
It is a bit.
Okay, so what if we had a not close of that, a close of that, and a hang in there of that? And we wanted to print these and format them in such a way that the columns will line up. So what we could do is this. We can say this, 0. Well, we'll start off with this first. So if I run this, you see that we don't get any padding at all. But we can actually get a lot of special syntax inside of these curly braces to get stuff formatted the way that we want it to. For example, I could say, comma 13. Comma negative 13. Comma negative 12. There we go. Then I could say, comma negative 12. And I could say, comma negative 12. There we go. Okay. So what we've done here is we've told the String.Format that we want to do some padding. So that's a really nice little feature that we can use. There's a lot of other things, modifiers that you can use, but definitely go ahead and check those out on the on MSDN documentation. Maybe one of them I can show you is, so this is padding. So if you specify a comma, the index, comma, then the padding, we're able to pad our numbers. But if we wanted to format them like percentages, we could say colon P1. And this will say, this will format this like 1300% or 13,000%, for example, for whatever reason.
It's because it's 134.
You what?
The 134 in the number are coming from the 134 in not close, not from the
right. Yeah, 13. Yeah. Well, if I had a float, it would represent a lot better. If I had a float of like 0.0, so if I said, float of 0.02f, it will correctly format that as 2.0%. And I could say P3 to get 3 precision. I had a question, why minus 13 and not 13? This is going to be right padding, this is going to be left padding. If I were to specify 13, it's going to pad to the left. If I were to specify a negative number, it'll pad to the right. So you see, this is 13, positive 13, and then this is negative 13. It's just the direction that it pads. There's another modifier that you guys might want to use called N0 for formatting numbers. So for example, if my close was this big, by saying N0, I say that I want to format this like a number based, and this is very important, based off of our current localization. So if all you people in the UK tried to do this, you'd get a period right there. Very cool feature about .NET, how it's completely aware of where the program is being executed from.
No, we wouldn't.
You what?
We use a comma there.
Oh, well, who uses the dot then? Is that just
the dot is the decimal point.
Well, I know, but there's other countries that use a dot instead of the comma. Europe. Isn't the UK in Europe?
No, there's other countries that use the comma instead of the decimal point. That comma isn't a decimal point, it's indicating thousands.
But aren't there countries that use the dot instead of the comma in those cases? Some people are saying Germany or France or Denmark does, apparently.
Wow.
What if your string is longer than 13? I believe what it'll do is it will just let that happen. Oh, come on. Oh, come Actually, just, you know what? It'll just let that happen. There might be a modifier that will prevent this behavior, but I'm not aware of it off the top of my head. But anyway, so I just wanted to point out there is documentation on this. This syntax can also be used with things like dates for date formatting, or basically any object that has a special overload of toString. And so it's really powerful little syntax you can use to quickly format things like percentages or numbers and padding and all that cool stuff. So just head over to the String.Format documentation. I'm not sure how you can center pad. I've never tried to do that before. I wonder if it's like, no, that's an exception. Okay, I don't want to get too much into this because I could go on for days about the different String.Format
That's why I'm saying be careful.
But I just wanted to point out that you can do some really cool stuff. Can you get numbers to show the leading zeros? Actually, I know you can, but I can't remember what the syntax is. I can't remember what the syntax is. It's something. Ooh, it's if you provide a character before this. So if I said, oh, 13, or not, apparently they lied.
Do you need single quotes? No.
I don't know. Well, you can look it on Google. Okay, what is P1 and P3? P3 is saying that this is a percentage with 3 precision. If you look at this, you'll notice the 3 decimal points. If I were to change this to P1, you'll get 1 decimal point. And 0 is going to be the same thing, but meaningless, simply because this is an integer. But you can still get it to display the period there by specifying N2. And then you get 2 levels of precision after under 0 or under 1. Can you use a variable for padding? There's nothing, well, I don't think so, actually, now that I think about it. I mean, I guess what you could do, you could do that, but that's kind of gross. I would just, this is more or less something that you would want to use as a constant sort of thing.
And we're going to have,
is there formatting?
All right, I'll answer this last one, but then we're going to have to jump back on track if we want to do the file I/O extra stuff today.
Right. Is there formatting for filling a phone number field? I doubt it. I honestly doubt it that would be built into the .NET framework, just because I'm aware of no type that understands what a phone number is. But there's nothing stopping you from creating a value object that represents a phone number and is capable of formatting itself. You can make them. All right. So is everybody good? Any more questions? Or, well, I guess no more questions. But.
Yeah, let's go ahead and move on from the formatting. The biggest thing that I wanted them to understand was just filling in the placeholders.
Okay. Alrighty. So, in .NET, there is the ability to read and write from files, provided to you by some types inside the BCL. So, some of those types that we're going to be working with, one of the main types is going to be the stream type. Although we're not going to be accessing it directly, and furthermore, it's not going to be accessible until we add a using statement at the top of our file. So everybody go ahead and clear out all your code. Make sure you have your console read key in there. And then add a using system.io declaration up at the top. So everybody get that up. Now that we have the using system.io clause at the top, we have now imported all of the types that are available to us through the system.io namespace. The main one, although we will never be using this type directly, the main type, we physically can't actually, but the main type that there is in the .NET framework for accessing streams is, well, the stream type. What is a stream? A stream is a type that's used to access a stream. A stream is a stream of data. It is a data. It's a potentially continuous block of data that may or may not end, that may or may not have any data inside of it, but it's simply a way to access a sequential group of data, meaning we can get a block of data, and then we can get another block of data, and then we can get another block of data, and so on. Or we could write a block of data, and then write a block of data, and write a block of data, and so on. So it's very, very useful type that's used from everything from file input and output to network input and output. We are not going to be talking about network input and output, but you would be using something like stream. Now, the reason that it's a little bit more complicated than you might think it is because files, when you open a file, you will not necessarily want to read the entire thing in. For example, if you were to open up a 10 gigabyte file, if you were to try to read that in, your program would likely crash because it ran out of memory. So a stream is very important to walk through a file and collect the data that you want, and then close it or keep it open for whatever purpose. Now, we are going to be talking about, for right now, we're going to be talking about the StreamWriter class. The StreamWriter class is a class that sits on top of a stream and provides us some very convenient methods that will allow us to write arbitrary text to a file. We'll be talking about the difference between text and binary data in a moment here, but this type will allow us to write arbitrary text to a file from any type that we might want to. If we were to instantiate a StreamWriter, okay, so I do want to point out, actually everybody go ahead and type this out. Type it. Type it faster.
Do it. Do it now.
I have a question that probably goes outside of the scope of this, but I habitually use a using rounders.
Yes.
Is that good practice, bad practice, or just
We're
habit?
actually going to be talking about that.
Oh, okay. I didn't know if that would be going beyond the...
No, we're going to be talking about it here very soon.
All right, so everybody have this typed out? Alrighty. Now, I know that there are some people in here who know what I'm about to say, but there are definitely some, this is going to warrant a little bit of a discussion for people who are new to C#. And this is the second example of thus far, or the third example thus far, of instantiation. Now, we saw instantiation with arrays, where we had int r equals new int 10. Now, this is a special syntax reserved just for arrays. We also saw how to instantiate lists. This is also a little funky looking because this is a generic type, but we saw that we could use the new keyword followed by the type we want to instantiate, followed by these parentheses. The same pattern is being used here. We declare that we want a StreamWriter variable of type StreamWriter, but we need to fill it with something first that will actually be able to perform operations. So what we do is we assign it to the result of the new operator. The new operator, again, just like in the case with lists, is going to start with the new keyword, followed by a type, followed by parentheses. Now, these parentheses in this case are very, very important. If I open up the list of parameters that can come into these parentheses, we'll get a variety of interesting things. You'll notice there are overloads. This right here is called a constructor, and it's a method that we can invoke when instantiating a type. And this constructor takes in a variety of different types. For example, we could pass in a naked stream into it, because remember, a StreamWriter is something that sits on top of a stream. A stream by itself is very kind of difficult to use because of the way that the API is designed. It's not very friendly. The StreamWriter is a type that sits on top of the stream to allow us to write data in a more easy way, essentially. So we can pass in a naked stream, or we can pass in a path. And this path is going to be the file path that we want to write data to. We can also pass in a stream and encoding, a path and a Boolean specifying whether or not we want to append to the file, and encoding in a buffer size, blah, 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 with the encoding, buffer size, blah, blah, blah. So you see it's a variety of overloads based on either A, a string, or B, a string. Now, if we want to go ahead and write out to a file, we'll need to instantiate a StreamWriter and use this overload. So we're going to pass in a string, and we're going to say, go ahead and write to output.txt. Now what this means is we are going to go ahead and tell the StreamWriter that we want to write to this very specific file. No, actually, it's not a very specific file. This is what's called a relative path. Does everybody here kind of understand the difference between a relative and absolute path? Because the question that we need to answer right now is, where is this output.txt? Okay, so we have a few no's. So we have this output.txt is a file, and StreamWriter, its behavior is, if the file does not exist when it goes to write data to the file, it'll go ahead and create it for us. So now the question is, where is this file going to be on our hard drive? This is an example of a relative path, which means it is relative to another path. And the path that it's relative to is going to be, by default, the path that the exe of our program is located in. Now, if you're using Express, if you're using Microsoft Visual C# 2010 Express, go ahead and do this. If you are not using Express, you don't have to. But go ahead and hit Control-Shift-S, and you'll get the Save Project dialog box. The reason is Express doesn't actually place your project in a location you can access when you create it. Now, all the other editions do, but Express doesn't. And we're going to have to explicitly save out our project to a very specific location so that we can view the project in Windows Explorer. So remember, Control-Shift-S, and then just hit the Save button. What that's done is now we have a file or our actual project on our hard drive that we can go ahead and take a look at. Okay, so we have our project. Let's find our exe, because remember how I said that this path is going to always be relative to our exe. So, well, in this case, and I'll show you the case where that's not true. So go ahead into your solution. Now head into your project, and again, I'm in Windows Explorer. Go into the bin folder, then into the debug folder. You will see a console application1.exe. Or console application whatever, or whatever.exe. This is your program. So you see I run this and we get the results of the last compilation. This is where the output.txt is going to be located if we were to run this program and actually properly save out the file. This is an example of a relative path, and it is relative to wherever on your hard drive the exe that your application is located. If I were to instead have done this, this is an absolute path. It's an absolute path because I specify a drive letter. If we were in Unix land, such as Mac OS or Linux, an absolute path would start with a /. But in the case of Windows, our application or the absolute path is going to start with a drive letter, a colon, and then a /. So for people who said no, that they didn't quite understand what relative paths are, do you kind of have a better idea now?
Did you cover did you point out that double slash?
Not really.
Because we haven't done.
Yeah, we haven't done
characters.
Escapes yet.
You could just make it a literal.
Yeah, I mean, you could do that either one. Okay, so, why isn't console application 5.exe, since that was a project file name specified on the onset? Does it default to 1 always? The reason is, there's a stupid reason why that's the case. When I created this project, it was console application 1, but then when I went to save it, Visual Studio said, oh, wait a sec, there's another console application 1 folder right there. Let's go ahead and make your save your project in console application 5, because that won't be confusing. So, yeah. That's the reason why my executable is different. Your executable should, if you're using Pro or anything above, it should be whatever the name of your project is.
And for the record, that's exactly how Visual Studio Express sounds when it talks to you.
Yeah. Can you open the Solution Explorer from the Solution? Can you open the solution in the Solution Explorer? You can. But I can't remember if I got that functionality based off a plugin or I got that functionality because I don't normally use Pro, or I don't normally use
I thought it
Express.
was a plugin. I
Okay,
thought it
it might have been a plugin.
I thought it was the Power Tools or Production Tools.
Okay. Well, I do on my main Visual Studio instance, but in Express, or if you don't have the plugin installed, you won't. Is C output.txt fine to use in Windows? It'll work. Well, actually, I don't think it'll work. Should throw an exception saying I'm not elevated. If I had done it into like my desktop, for example, this might be a better example because I know this will work. If I were to have done that, that would work. However, I would recommend not using relative or absolute paths if you can help it. Can you put the other relative notation used again, please? Yeah, the relative notation is simply going to be a path without a drive letter. Oh, he asked if this was valid to use in Windows. It isn't technically. Technically, Windows doesn't understand that, but there are a lot of scenarios where Windows will, behind the scenes, convert the different slashes to the right type. Natively, Windows won't understand that, just based off the syntax of UNC paths, or paths in general. But there are a lot of scenarios where programs and programming environments will convert that for you automatically, and I'm not entirely sure of the specifics of when that will happen. As a result, I always use backslashes when working in Windows. But for example, I find in PHP will silently convert the forward slashes to backslashes if you are using Linux or Windows, depending on which environment you're in. Ooh, does ... work as well? Yes. You can say, well, actually, we did have a question before that. Where does this go? This goes to the root of your C drive. So, for example, if I were to go at my computer, my C drive would be where the output.txt would go. I'm not sure if this would work. I don't think it will because of the security in Windows 7. I might have to be elevated to do this. So that's why I changed this to this example, because I know that this will be allowed. But this will simply go to the root of your C drive. So again, absolute path, relative path. Somebody also asked if this is valid. And the answer is yes. This syntax means go one directory above where we currently are and then place the output.txt there. Okay. Okay, so is everybody good on the different pathings? Oh, I just used this. I just had output.txt. The output sign is required because of some scenarios that we won't discuss. It's required for this syntax and this syntax, not required for this syntax. If you don't specify txt file extension, what will happen? Nothing. You will just get a file without an extension. Usable? Sure. You won't be able to double click on. Well, if you double click on it in Windows Explorer, it'll ask you what you want to open the program with, because Windows uses the extension to determine which program it should open with it. But yeah, it's perfectly usable. You can read and write to any file regardless of the extension. And no, we're not going to be covering autoexec.bat. I can't even believe I know what that is.
Yeah, I know. It's kind of funny. Just hearing you say that.
Okay. We are going to be using relative pathing for these examples because relative pathing is what you should prefer to use as much as possible. Simply because absolute pathing something will break depending on the environment that your programming is executing under and depending on where your program is physically located. So relative paths are good. And again, this relative path equals this path right here plus a file called output.txt. So is everybody good with where this file is going to go? Is there any concern about, what this file might? I could run it. And you'll see that we get a nice little output.txt here. The reason I was a bit hesitant to run it, though, is because this program is actually not... Actually, let me go ahead and remove all that noise. There we go. This program actually isn't something that you would want to do. There's some more code that we're going to have to add to get it to be proper. But I guess I could actually show that right now. So you see how... So the relative path is the directory that your program is sitting in. Yes, by default. That is changeable, but by default. I do want to point something out. You did see that output.txt did show up, but watch this. If I hit F5, oh, great. That's a bad example. We have to get actually into writing out to the thing before I can show that example. Because the StreamReader constructor does check to see if the file exists, blah, blah, blah. Okay, so let's pick a better example. Let's say we want to go ahead and write something out to the StreamReader. StreamReader is an object that we can use, and it has a very important method on it, or two very important methods on it, write and WriteLine. Does this look familiar to anyone?
Huh.
So we have this convenient little WriteLine method, and it looks, hopefully, very familiar. Not only does it have overloads for every base type, or most of the primitive types, it also has some format stuff on it too. So any guesses about how I would go about writing the string hello world out to that file? Oh, it looks like NATO already beat me before I even asked the question. Okay, so this is how I would go about writing text to this file. There is something interesting in this. The behavior of what I'm about to show isn't always guaranteed, but I'm 99% certain that this example will work the way I expect it to, because there is an issue with this code. If I hit F5, it's a joke. Hello? What? What? What is this madness? Hold on, let me turn off Synergy. That might be causing it. Yeah, it was Synergy.
Wow.
Okay, so now that we've done that, there's a problem with this code. If I run this program... Okay. Goodbye, Visual Studio.
Maybe there's a problem with your code.
There can't be.
It's meant to be.
Look at it. It's just...
Yeah, that's extremely odd.
It was about time for a break anyway. Could I just go ahead and restart my VM?
Yeah, that's fine. So, yeah, we're at 1 hour and 50. Let's go ahead and take a quick break. And 10 minutes, we will resume. So go ahead and pause the video.
Yeah,
Resume. All right, and we're back from break, guys.
Alrighty.
So let's pick back up where we left off before your machine exploded.
Yep. Also, Gav's on admin.
Oh, wow. I wonder how... Did he disconnect?
Yeah, he besotted.
Oh, okay.
Okay, so we have some code here, and this code kind of looks like it should work. You know, it's pretty straightforward. We instantiate a StreamWriter, we set it to a file, we know that the file is being created, although it's empty, and then we write out to the file, we do a read key, then we end the program. So if I run this program, let's see, we don't get anything because we're halted here on line 16 on the read key. If I go ahead and hit something and the program closes, we should have, what do you think is inside of output.txt, everyone? Because I said it wouldn't work. Oh, we have one hello world. The answer is, yeah, no, they cheated. Dstu gave it away. We get nothing. There's nothing in this file. The reason there's nothing in this file is that we never told our program to flush or close the file. Now, what's a flush? To avoid a bunch of extraneous disk usage, our StreamWriter classes in the BCL are what they're going to buffer every single thing that we send into them. And when we send in data, they're not going to actually write out anything to the file until we tell the StreamWriter to close its buffer. Either close its buffer or flush its buffer to the file. And there's two ways we can do that. We can say StreamWriter.flush directly if we wanted to. And you'll see clears all buffers for the current writer and causes any buffered data to be written to the underlying stream. Now, remember how I said StreamWriter is a wrapper over streams? This constructor actually does some work for us. It creates a file stream and wraps the file stream inside the StreamWriter. So the underlying stream in this case is a file stream. And when we say StreamWriter.flush, it's going to take all the buffered data that we've sent it and flush it out. Now, the StreamWriter can flush whenever it wants to. I want to point that out. There could be conditions in which the StreamWriter will flush out its buffers to the disk. But in this case, we are telling it to manually flush out the data. Actually, I can go ahead and even do better than that. I can stick this underneath our read key. So I'm going to go ahead and hit F5. Does anybody have a guess as to what is currently in the output.txt file? Okay, I'm going to go ahead and press key. Now does anybody have a guess as to what's in the output.txt file? We get hello world. And again, the reason is because we have flushed the StreamWriter's buffer. There still is a problem with this code. I'm going to go ahead and put the flush above, but I want somebody to guess what the problem is with our code currently. Chris asks, so you can write multiple lines to the output file and then flush them all at once? The answer is yes. But remember, whether or not it flushes during a write process is up to the StreamWriter itself. If you were to write so much data that it would fill its internal buffer, it could decide to do a flush at some point. Okay, so we have a lot of good guesses. What we have right here is an unmanaged resource that we never cleared. What I mean by an unmanaged resource is that the underlying code of StreamWriter is going to open what's called a file handle, meaning it says Windows. I want to write to this file. And of course, Windows is technically, the operating system is technically responsible for doing that, performing that operation. So we ask Windows if we want to write to a file. And Windows says, okay, you're allowed to write to this file. Have a file handle. And the file handle is just an arbitrary identifier so that we can continuously reference this open file handle to this file. But we never give it back. Now, Windows will detect at the end of our program that we do have this unmanaged resource and close it for us, but generally that's very bad practice to not close your file handles, especially when you open and open and open additional files during the execution of your program. When you're done with a file, or when you're done with any unmanaged resource, you will always want to give that resource back to the underlying operating system. So what do? We invoke the close method. So when I run this program, still get the exact same output. If I were to delete this, for example, if I were to delete this entire file and run this, we'll get our nice little output.txt with the text inside of it, which is good because we closed the file, we've flushed the buffer, and we've given the handle back to the operating system. So that's. I hope that concept is a little. I mean, does anybody have an issue with the concept of requesting a resource from the operating system and then giving it back when we're done with it? Darth Greg asked, but you didn't flush previously, not in the current build? No, close does a flush for you.
So when you had flush there rather than close, if you were, if before hitting your read key while the program was operating, you presumably at that point wouldn't be able to delete output.txt, for instance. Would you get the message from Windows saying?
It depends. It depends. I'll try it right now. Yeah, in this case, this action cannot be completed because the file is open in vhost32.exe. So yes, the answer to that question is yes. There are ways to get non-exclusive locks on files, and previous versions of Windows didn't have the same sort of locking mechanisms. But in this case, we cannot delete this file because it is open in another program.
And that's essentially what happens until you either flush, until you close it, really.
Yep, until I close it. And then the handle is removed. If instead I were to do a close right here, we'll still get our nice little output.txt. But because I closed before we entered this console.read key, I can still delete it. So I'm not really following this whole thing. What aspects aren't you following as far as the concept of closing and flushing, or the concept of writing something out to a file? Okay, the difference between closing and flushing is a flush. Please not get any bad typos in that. A flush is going to be the concept of taking everything that the StreamWriter has accumulated and writing it to the file. So the StreamWriter will continuously accumulate data that you send it to it. And then it will not actually perform the write operation until the flush happens. And the reason is because you don't want to continuously write out to the disk, because you would run into situations, hard drive input and output operations are very expensive compared to simple memory reading and writing. So you wouldn't want to continuously write to the hard drive as you accumulate data. So the StreamWriter has this internal data structure that will store the data that you have asked it to write up until the point where it's flushed. And then performs the entire write operation on this single line. So it has all the data already there, and then it prints it out to the screen, to the file. A close does two things. A close does a flush, but not only does it do a flush, it closes the file handle, meaning it gives the file or control of the file back to the operating system for other use. StreamWriter doesn't append to the file, it overwrites it, correct? Yes, well, in this case it does. There is a way to get the StreamWriter to append to the file, but in this current configuration, it will simply overwrite everything in the file. So if you format text in a certain way, it'll write out to the file in the same format. Yes. If I were to say, int number equals 10, I could say StreamReader.ReadLine, my number is 0, number. If I were to run this program, you see the output now contains hello world, and then on a separate line, my number is 10. Okay, there's a buffer there. Is there a way to know how big that buffer is? Is there a way to manage that buffer, say make it larger or smaller? That's a good question. That is an implementation detail of the StreamReader class itself. You should not normally interact with that sort of low-level detail. The only way that you can interact with that low-level detail is with the auto-flush property. If I were to specify auto-flush equals true, every time I say WriteLine or write or any of the derivatives, it will automatically flush. If you read the documentation on auto-flush, you see it says, gets or sets a value indicating whether the system.io.StreamWriter will flush its buffer to the underlying stream after every call to the system.io StreamReader.write method. So you should really not worry about the internal buffer. Again, that's an implementation detail. If you wanted to write your own buffer implementation, then simply write your own text or StreamWriter class that interacts with the underlying stream in a different way.
Did that tooltip say that it flushes after every character?
No. The most basic overload of StreamReader
Okay.
is, I believe it's going to be this. This is the most basic overload. Every other overload of the write and WriteLine methods use this one method. So by saying Console.Write or StreamReader.ReadLine hello world, it's going to behind the scenes invoke StreamReader.Write and then pass in an array of characters. I don't get what you mean when you say flush is continuing to write to the file. Well, a flush will allow you to write everything out to the file and then continue to use the string. And then I could say flush again, and so on and so on. If I instead did close, it will flush, but then you'll see I'll get a nice little exception because we've closed the StreamWriter and then tried to continue to access it. If instead I were to do a flush, you'll see that I can continuously write to the file even before it's closed. Will it append or overwrite the file? It'll overwrite it. That's the default behavior. That can be changed. Aaron Rico, yes, we are definitely going to be covering that, but I kind of want to leave that as a mystery / question for people. When would you want to flush and then keep writing to the file? Not very often. Generally speaking, I will allow the StreamWriter to perform whatever buffering operations it wants to perform, as those have been, optimized by the writers of the BCL. And I wouldn't find very many scenarios that I would flush intermittently. Rather, I would allow the StreamWriter to flush whenever it needs to, and then at the end, when I'm done writing to the file, I'll just close it. Like I just said, Wolf Knightley, he asked, I still don't get why flush is bad and close is good. Flush there's no real reason to use it unless in very, very specific scenarios. I just wanted to point out that the flush operation is indeed what clears the StreamWriter's buffer, but the close operation does too. Generally what I'll do is I will write to the StreamWriter as much as I want, not worry about flushing the buffer because that's its own, that's its own implementation detail. It can do whatever it wants with this buffer. And then when I'm done writing data, I'll just simply say close. Dave, I'll get to that. So you should re-ask that question when we start doing a few more things. Does the using on, then we're getting to that. Florin. I mean, multiple flushes on the same open file, append, yes. Oh, yes, Chris. If you have multiple flushes, that'll continuously append to the stream. Meaning this will continuously append to the StreamWriter. But if I were to open up a new StreamWriter, then it would clear out output.txt. Is there a way to reopen the file once you've closed it? You generally wouldn't want to do that on the same object, and in this case you can't. Some of the things that some of the other types that allow you to access streams can be reopened, but the StreamWriter cannot. If I were to want to reopen my StreamWriter, the only way I'd be able to do it would be reinstantiating it. So I would have to say StreamWriter equals new StreamWriter output.txt, and then I can write to it again.
But Nelson, now you've put all that text out there, how can we use it?
As far as reading?
Yeah, if only there were a way to do that.
All right, so I just want to make sure everybody's good with this. I think I just answered most everybody's questions. Then we can look at actually using the data in a useful way. And if anybody asks questions in BuzzNet, I was so focused on the questions panel that I would have missed it. So post your question in the webinar. And Rico asked, what happens if you don't close the StreamWriter and open another file? Bad? No. You can open as many files as you want. Okay. So I see people are already guessing as to whether or not there exists the opposite of the StreamWriter. And there is. It's called, not surprisingly, the StreamReader. StreamReader is a class that allows you to read text. Now, reading text is a little bit more complicated than writing text. So you see what I did here? I started off with my StreamReader. I instantiated it to a new StreamReader object, and I specified that I wanted to use the output.txt file. Then I closed it. So in between instantiating the StreamReader and closing it, I'm going to go ahead and want to perform reading operations. If we look at this class, you'll see some things in it. These are going to be your main methods that you'll be using. There's the read method. Now the read method, I don't think we're going to be talking about the read method. It's a little bit complicated to use. The situations in which you would want to use the read method would be if you are working with a very, very, very big file that you cannot load in all at once into memory, you will use the read method to stream in the data byte by byte or buffer by buffer and act on that data as you are reading it. However, we're not going to be talking about that because that's going to be a little bit more complicated. We have the read block, which behaves a very similar way, of course. But we have these two methods, the readLine and read-to-end methods. These are the ones you're going to be using most often. The read-to-end method is the simplest. Can anybody guess as to the output of this program? All right, if I go ahead and run this, we get everything we printed out to the file printed back to us. We get hello world, my number is 10, and then a hello world and a hello world. And we get a new line too. The StreamReader.ReadToEnd method will read in all of the text. What about this method? Any guesses as far as what is going to happen now? Yep, we get the first line, hello world. I'm going to remove some of the code up here, and everybody should go ahead and write this code out. So go ahead and hit ready once you get this written out. Do you want to pause the video, Jason, or do you think?
No, I'll go ahead and pause it because it might take just a few minutes. All right, and we have resumed.
Okay, so somebody did ask how do you append to an existing file that's been closed? We'll talk about that here in a second, because I want everybody to do something. I want everybody to use the StreamReader.ReadLine method to read in every single line of the file and print it out to the screen. The one hint I will give you is that StreamReader.ReadLine returns null when there are no more lines. So go. So this is just using some existing knowledge that people have previously had. Go ahead and get the StreamReader.ReadLine method to print out all the lines of the file using some existing knowledge that you have. So the one hint is StreamReader.ReadLine will return null instead of the current line when there are no more lines in the file. So we already have one ready. And again, if you just hit 1 minute while just to indicate to us that there aren't any AFK people. If you are working on this, just hit 1 minute.
Thank you. Good deal.
And as far as whether or not this is, because remember there is the read to end method, but if you are reading from a huge file, you will want to do what you're doing now to read from that file. In fact, I would recommend doing what you're about to figure out when reading from text files as much as possible so that you can collect data as you're reading through the file and consume as little as memory as possible. Because once you start talking about file input and output, those files can be arbitrarily large, and you wouldn't want your program to crash if they get too large. Wait a second, about 45 minutes away from Bellingham? Oh, sorry.
Okay, so resuming. Let's go ahead and code this out, Nelson.
Okay. So what we would do is we would start with a string current line, and we would say while equals null. And we would say while current line does not equal null, or I'm going to do this differently. The way I traditionally do this might look scary, so I'm trying to do this as
easily as possible from a beginner's perspective. The end. So go ahead and leave that there for those that want to copy that down real quick.
Yep. We just enter an infinite loop, grab the current line from the StreamReader. We check to see if it's null. If it is, we break out of the loop. Otherwise, we print that out to the console.
Is that something that you would do in production code while with a, infinite while with a break?
Yes.
Is that cool?
But I would generally try to keep my methods as short as possible, and definitely in a scenario where I am doing infinite loop, I would want the break to be, well, I wouldn't want a loop that was greater than one screen worth of code in the first place.
Yeah.
But I would take special care with an infinite loop to make sure the breaks are obvious at first glance. How do you reset the file pointer back to the beginning of the file? That gets a little bit more complicated. I don't know, Jason, if you want to.
No, I want to keep this simple for now. Anyone that wants to go out and look that up, it's not difficult to find. But I want to keep this, since this is extra content and it's making this class longer, let's keep it focused.
Okay, so is everybody done who wants to copy this line or this code out? Because now we've talked about basic output, we've talked about basic input. There still is a very big concern that we have. Actually, two things. A lot of people were asking about appending to files, and there are many, 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 many ways we can append to a file. But I do want to point out the simplest way, and then move on to one last thing, and then we'll move on from strings. How does it know to move on to the next line? Good question. The StreamReader looks for end-line characters, so the special control characters that indicate whether or not the line should be broken. Okay, is anybody else still copying? Because I'm about to move on. All right, well, let's move on. So what if we wanted to append to a file? Well, like I said, there are a million ways we can do this, but the easiest way to do it with the StreamWriter class is to add a comma and a true. That's it. If you want to append to the file instead of overwriting it, just say comma true. So now if I run this again and 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 again, you'll see that we are indeed appending. Chris asked, no, I mean, why does it not print the first line over and over? Okay, because what it's doing is it's advancing the internal stream pointer forward every time we say read line. But that does get into something a little bit more complicated. Okay, the last thing when we're talking about streams that I want to cover is a new bit of syntax. What happens right here? We got some booms. Yeah, that does happen, but something a little bit more important happens. Or more specifically, something a little bit more important doesn't happen. Yep. Any guesses as far as how to make sure that the StreamWriters will always become closed no matter what happens or doesn't happen during your code?
Nice.
Sweet. So people said try. And finally, okay. Well, this actually doesn't work. And this actually brings up a great point. There is a scoping issue here. StreamWriter is not accessible from the scope because StreamWriter is defined in a scope that is not a child or is not a parent scope to the finally scope. What we have to do is we have to say StreamWriter equals null, then instantiate the StreamWriter, then close it. But with this code, we can guarantee that our StreamReader.close will always be invoked. Now, this scenario is so common that there is a way to do this in a very simple way. There's a way to actually have the C# compiler write this code for us without us having to write the code. So you'll see the same pattern right here. We still have a problem with our reader. Our reader does not get closed if an exception happens. So watch this. This code is almost exactly turned into this. And I will say almost exactly because it's not entirely, but it's close enough for the purposes here. We're not going to be talking about interfaces or how this works behind the scenes, but you can think about this syntax as being this code right here. The using statement will wrap this variable in such a way that it does get closed no matter if there is an exception or not, including a situation where I would return out of the method. If I were to return it out of the method, because the using statement does get turned into a try finally, the StreamReader still gets closed at the end. So does anybody have any questions about what a using statement is in this context and what it can be used for?
I'm going to make an exception and read a question from BuzzNet, but Rolling Stone just said, but you never called close?
Nope. There is a method on the StreamWriter called, or StreamReaders and StreamWriters called dispose. Now, in the case of StreamReader and StreamWriter, dispose is synonymous with close, meaning these methods do the exact same thing. The reason why there's two of them is that dispose is a special method that the using statement knows about. The using statement will automatically invoke the dispose method on this object, whether or not there was an exception thrown inside of the using statement, or whether or not the using statement returned a value, or just returned. Yeah, Segfault says, I presume dispose just calls close. Yeah, that's probably how it works. In this case, close can cause an error if the system could open output.txt, will it not? If the system can't open output.txt at this point, an exception will be thrown. That exception will not be caught, meaning the exception will be thrown right here if output.txt cannot be located, and it will not be called by anything in the using statement. Therefore, the close method will not be invoked. Well, all things you should have wrapped in a using have a dispose. Everything that can physically go into the using statement will have a dispose method, period. Now, it might not show up if you hit dot actually because of explicit interface implementation, but that's irrelevant. Even if you can't access it, every single object that you put in a using statement will have a close method. Is this the same using keyword as using system? No. This is the same keyword technically, but it is used in an entirely different context that has a completely different meaning. But just to drive home the whole thing about the dispose method, if I were to say, for example, using string I equals hey, I would get a compiler error here that says type used in the using statement must be implicitly convertible to iDisposable, which just means this object doesn't have a dispose method on it. So, is everybody good with this using statement? Segfault, no. It must be. I'm saying that it has to have the dispose method just to keep things simple. Okay, any questions about using? Because we're about to move away from streams for now, or indefinitely. Questions, questions, questions. I mean, I guess because it has been another hour and we are about to move on to something completely different, I could just leave this code up on and see if...
All right, take a break.
Yeah, just because I'm sure there is somebody with a question right now, but
all right.
They haven't realized it yet.
Well, for those of you that are wanting to copy it out, now's a good time. If you have not, let's go ahead and take a break, and then we'll come back, and we've got 2 things left to take a look at. And we will see you guys shortly. I'm going to go ahead and pause. Zooming. And we're back.
Okay, so these are StreamWriters and StreamReaders, and now they're gone. So moving on to what we're going to be talking about next, we're going to be talking about enumerations. Enumerations are a type, and they're going to be the first real type that we're going to be creating in C# other than our basic program type. Enumeration type is a very straightforward type. It's a type that can be one of any particular values that the enumeration allows for. Remember that a type, a basic definition of type is what that type can accept. Remember, ints can accept numbers, like whole numbers. Floats can accept floating numbers or floating point numbers. Bools can accept 2 values, true and false, and so on. Now, what if we wanted to make our own type that can accept values, the only values that we specify? Well, we can. So what is this? This is a type. We have created a new type. The type of this type, or the kind of this type, is an enum, short for enumeration. To create an enum type, we start with the keyword enum, followed by an identifier. This identifier follows the same naming patterns that we will be using for all types that we create, including program. So we start with an uppercase character. The next thing that we do is we open up curlies. Now, inside of these curlies are going to be very different than what we'd put inside of a class. We don't put members in here. We don't put any executable code in here. The only thing we can put in here are comma-separated list of identifiers. That is the only valid thing that we can put inside of an enumeration. I do want to point out that there is, inside of the language Java, which I normally don't like, actually has better enumerations than C# enumerations, where you can actually put methods in them. They're pretty cool, to be honest. But in C# our enumerations are going to be limited to just identifiers. So what does this mean? This means we have created a type that can be of one of three values: identifier 1, identifier 2, and identifier 3. So we can say my enum equals my enum dot identifier 1, identifier 2, and identifier 3. We can change the value of an enum during the course of execution. We can say the enum equals my enum dot identifier 2 if we wanted to. We can compare enum values to any of the valid values inside of the enumeration. So we can compare the enum to identifier 1, 2, and 3. Can anybody guess what the output of this code is going to be? Any guesses? We got a false, we got a true, we got a true, we got a true. Oh, no, we got a true. T-U-R-E. Tour. We got a false.
Got a giant smiley face. I have no clue where that came from. James.
We have a you're stupid. Should be pretty impressive.
That'd be the start of Skynet.
Yeah.
Wouldn't it be great, though? You type a program out, you hit run, and it just says something completely sarcastic that you didn't expect at all.
I really got to pull up those JavaScript examples where you can get just punctuation to print out any arbitrary number or any arbitrary text that you want.
Also, for the next class that we meet for open office hours, you need to get that link that you sent me that one day where the guy was comparing different languages. Oh, God, that was so funny.
It was hilarious.
Yes, it was.
Okay, so I'm going to go ahead and run this, and we get true. The reason we get true is, remember, a type is going to identify what values that type can hold. We have created a type that is constrained to only being able to contain three values: identifier 1, 2, and 3. We initialize that variable of type myEnum to identifier 1. We then change it to identifier 2, and then we compare it to a value. And we can only really compare it to a value that is of the type that we created right there. And I locked somebody out of my house. So I'll be right back.
That was the most
Fantastic.
That was the most random thing in the middle of a lesson that's happened yet. Let me just hit pause real quick.
Okay. So enumerations.
Hang on.
I started it back as soon as I heard him sitting back down.
Oh, sorry. I'll shut up.
Okay, so this variable, again, is of type myEnum, which is a custom type we created that can only support three values. And we can set it to any of the values that we specified, and we can compare it to any of the values we specified. If anybody here is previously familiar with enumerations, you might know that there are integer representations of enumerations. In fact, it is possible to do some mathematic operations with enumerations. However, I don't suggest using enumerations for that purpose. The reason is that conceptually an enumeration is a type that is constrained to any of the specific values that you allow the enumeration to be of. Their numeric representation, unless you are doing unless you are interrupting with other languages or other pieces of code that require you to represent enumerations as integers, I do not recommend doing that from a design standpoint. Enumerations are conceptually, generally, when you write them, they're going to be simply constrained to the values that you allow them to be constrained to. Philosophically, they are not numbers. So I want to point that out. And we're not going to be going over how many or how to convert between numbers and enumerations here.
Christian had a good question in the webinar questions.
Can I get the number of how many identifiers are in my enum? You can. you can say enum dot get names type of my enum dot length. This will tell you how many numbers are inside of your particular enumeration. So I can say int number of items equals this. However, we're not going to be talking about that particular method. We will be talking about another method in a second here. So why are enumerations important? Enumerations are good at, specifically, they're good at recording the current state that something could be in. So we could say enum program state. We can say main menu, add item, display items. And we could say something like program state equals program state dot main menu. And we can say while true, if state equals program state dot main menu, Console.Writeline 1 add item to display items. Then we can say if state equals program state dot display items, we could display items. If state equals program state dot add item, we can add an item. And then we could simply store a list of items over here. And when we display items, we could say for each string item in items, Console.Writeline item. And then add item could simply be items.add Console.ReadLine. So how would we switch between states? Well, we can go ahead and say int choice equals int.parse Console.ReadLine. If choice equals 1, state equals program state.add item. If choice equals 2, state equals program state.display items. And then for reasons I'm not going to explain, we're going to move these above. And then, so now we have a state movement here, or a state change from the main menu to an add item or a display item state. Inside of our display items, well, actually, this is going to be a catch-22 anyway. I want my else ifs back. Fine, I'll use a switch.
And you will type it out by hand.
Unfortunately. Okay, so if I go ahead and run this program, I'm going to add a console.clear at the end. Go ahead and run this program. I can go and say, I want to display the items. There's no items. So let's go ahead and add an item. Let's add an item called item 1. Now let's add another item, item 2. And then another one, item 3. And another one, item 4. And another one, derpy. So now if we hit 2 and hit enter, we'll see all of our items.
Lovely.
So what's going on here is we are using our enumeration to record what state inside of our program we are currently in. We start off with our main menu, and what happens here is we enter a switch, and we use the switch to determine which block of code we should run given a particular state. Now, the main menu state is the most straightforward state, where it just says Console.Writeline main menu, and it displays the main menu. It retrieves input from the user to determine which choice they made, and then it detects which choice they did select, and it changes the state depending on their user input. In this case, okay, so then we break out. So if we switched over to either one of these states, the next time this while loop iterates over, remember this is an infinite while loop, we're going to go ahead and loop over, and if we chose the display item state, this code will execute, where we print out the word items. We loop over all the items in the item collection, and we write them all up to the console. And then we tell the user, press any key to exit to main menu. We do a console.read key to pause the console until the user enters a key, and then we switch our state back to the main menu. In the case of an add item, we do similar things where we ask the user to enter an item, and then we move over back into the main menu. So using an enum for this is better than using an integer. Yes, we could have simply used an integer instead of an enumeration and switched on the values 1, 2, and 3, for example. The problem with that is that makes the code very difficult to read and understand. Enumerations are there in cases where you want to give semantic meaning to what would traditionally be represented with numbers.
And the difference it can make to the readability, just the amount of time it takes to read through code, is astonishing.
Yep.
Because you end up with far more plainly readable code.
Yep. Okay. So are there any questions about enumerations, or at least what we can use enumerations for in particular? This is kind of like the de facto standard example for using enumerations because they're so well suited to determining state. But anything that can be in different states should be represented with enumerations. Do what?
Colors is a good example of a built-in one.
Greg, yes, but that's going to be part of the homework. Elevating asks, are you supposed to claim it outside of the class? Not sure I understand. I defined the enum type outside of the class, meaning that this enum type is accessible to every other code file in this project.
Yeah, declaring it, I think is what it means.
Actually, yeah, because this is the first time you've declared something that hasn't been inside of program, isn't it?
Yeah, I think it is. This is the first type, the first kind of type that we can create in C#, and consequently the simplest kind of type we can create in C#.
But you can create it in script, can't you? Or is that going beyond what you want to talk about?
Yeah, yeah, we could put it there, but I don't. Once we get into the next lesson, then I think that'll make more sense. So is everybody kind of comfortable with our cases here? Or, sorry, our enums. They're, again, a very simple type. They are constrained to whatever values you specify. And although it is possible to use a numeric representation to convert between integers and enums, I'm not going to talk about that because I personally find that design bad.
Sorry.
Okay. So what if you wanted to get the name of the current enums? What if you wanted to get the string representation of what the current state is? Well, you can. I wanted to say Console.Writeline, the current state is. Oh, it feels so nice to finally be able to do. If I were to do this, what would the output of this be on line 25? Any guesses? And I'm talking about the first iteration of the loop. We got some main menus. We got some program stat.main menu. Current state is main menu. My state.main menu. Gasp, I don't know, LOL, which I sure hope it isn't.
Tense answer, AFK.
Yeah. We got a 0. We got a hello world. Okay, I'm going to go ahead and run this. Oh, come on. Are you kidding me? Give me a sec. Don't tell me that they changed this behavior, because that'd be very upsetting. Jason,
You need to
help.
two-string it. I know that you're going to want to say that's the default, but I'm just curious.
It's bent on giving me this this output, although I could have sworn that's not.
That's how I've used it in the past.
Huh.
Is that the only Visual Studio you've got running?
Yes. At the moment. I think I have another one on my host. Okay, well, in this case, this prints out everything that we want it to.
Huh?
Yeah, what?
So we get our proper state, given the exception. Another thing that we can do, the way that a particular method here, which is the name of the constant, the specified enumeration has the specified value. The enum.getName method is an example of a method that allow you to get the name for a particular enumeration value, but it seems that the two-string implementation is smart enough to do that for us. So in that case, all you need to do to get the current identifier of a particular enumeration value is simply either write it out to the console with the String.Format or call toString on it, or yeah.
Take it easy, Marion. Was it not showing main menu a minute ago?
No, it's been showing main menu.
So it was fine the whole time. Yes.
I could have sworn that default behavior didn't exist, but I don't know.
He was aiming for a mistake and got the right answer by mistake. Well, now here's the thing.
What?
Ooh, lag. But is it possible? Like, I assume it's not possible to have spaces in.
No.
Obviously, the idea would be to have main and menu as two words. When it, in the current state is main menu. You can't have. Sorry, lag's really tripping me up today. I think it's bandwidth, mind.
Okay, so at least up until this point, does anybody have any questions about enumerations now that we have been able to successfully print out its name? Oh, you know what? You know where I was getting tripped up on?
Uh-huh. No, same thing. But I know what you're thinking.
You know, if they change this behavior between CLR versions, then maybe I just have a really bad memory. So ignore me. Okay, syntax seems easy enough. Yeah, it is very straightforward. This is the simplest type that you can create yourself. So yeah, I mean, are we ready to move on to
Yeah, I think so.
basic debugging?
Yeah.
Alrighty. So, does anybody here know what the debugger is? Something that can remove bugs. You can buy it at Camera 8. Yes, you can. Okay. The debugger is a program that runs parallel to your running application that will actually reach into the process and allow you to introspect the execution of your program as it's running. The Visual Studio IDE has a bunch of functionality that integrates with the .NET Debugger that will allow it to show you the execution of your program as it continues. Allow you to do a variety of different things to watch everything that's happening inside of your program as it's running. It'll allow you to pause your program. It'll allow you to continue your program at specific steps. It'll even allow you to change your program and execute additional code as your program is running. Dave asked, haven't we seen some of the debugger actions when we got the exception errors? Yes, we have. If I were to go ahead and say int.parse ASDF and hit F5, this is what the debugger looks like. Now there's a variety of windows that will appear by default that I've hidden. So this is what a default Visual Studio Express debugger would look like. So let's go ahead and talk about the most basic form of debugging, and that's going to be the breakpoint. The breakpoint is going to be a position in your program of executable code. Now it's important that is executable code. Placing in a non-executable code is not going to work. As you can see, I can't place it on the usings or the namespace or anything else. So a breakpoint is a position within executable code that will cause your program to stop running during the debugging session and jump into the debugger that's attached into it. So if I go ahead and hit F5 right now, and remember, F5 is the shortcut for start debugging, if you've never noticed that. So if I go ahead and hit start debugging, you'll see our program is actually paused. And I can go ahead and have it run side by side. So the program is actually paused, and I can look at everything that the program is currently doing. I can even tell the program to execute a line. Now, when you see this yellow line is going to be the next line of code that will be executed when I hit the F10 key. The F10 key is what's called step over, and you'll see that in the toolbar up above. I can hit step over, and what step over will do is it'll execute this line of code and then sit on the next line of code. So if I go ahead and hit F10, this line of code is now executed, and now I'm on line 20. Or more specifically, I'm at the beginning of line 20. When I hit F10 again, we go again. When I hit F10 again, when I hit F10 again. Okay, so if I hit F10 again, what do you think is going to happen? All right, so if I hit F10 again, we have output. So if I hit F10 again, so now you see we've reached into the state. Now here's what's interesting. If you mouse over any of these variables inside of your window, you will see their current value. Meaning if I mouse over this state variable, you'll see that it contains main menu. Furthermore, I can go into the locals window that appeared. Now these windows right here, the locals, the watch, the call stack, the immediate window, and the output window all appeared when I entered debugging. Normally they don't show up. So if I jump over to my locals window, you'll see my state is main menu, my items has a count of 0, my choice variable is 0 right now because choice hasn't been assigned to anything, and we have the args variable that's not filled up yet at all. So now I can continue to hit F10 and watch everything appear. Now we're on an interesting line. What happens? What do you guys think is going to happen when I hit F10 one more time? We do have some if checks. Remember that this yellow line is the line that's going to execute when I press F10. It's the line that's about to be executed. So if I go ahead and hit F10, you'll see we're no longer debugging anymore. We're not debugging anymore because we entered the Console.Writeline method, which has actually paused the program, or at least paused the rest of our code until I enter a value over here. So if I go ahead and hit 2 and hit enter, you'll see we enter back into the debugger. Now if I hover over choice, we will see that choice is the value of 2. In addition, if you look at down the locals window, you'll see that 2 is red. And the reason it's red is because it just changed. Now if I hit F10 again, you'll see we jumped over that if statement, and then we enter this if statement. But right here, choice is 2, and if 2 equals 2, then we enter this if statement, which we do. Now, if I hit F10 again, you'll notice state becomes red and turns into display items. So then you'll notice that we break. We hit the console.clear method, clears the console, and we continue from the top. And notice state is now display items. So if we enter this loop, you'll notice this loop does nothing. The reason the loop does nothing is because the items has nothing in it. You'll see the count equals 0. And so we can keep on doing this continuously forever. Okay, so is everybody good with the basic step over inspecting variable? Basically, step over and inspecting variables. Are you guys good with that? Now, the debugger acts a little bit differently once we start talking about multiple methods. I'm going to go ahead and fire up another Visual Studio instance because I don't want to lose that project for now. And I'm going to write a basic program that has multiple methods in it.
What Nelson's typing at the moment is particularly of note to any of you who plan on using Unity. It's a very handy way if you get stuck with something that you just can't find to get some feedback. Obviously, you'd use Unity's debug.log, but instead of Console.Writeline. But I just thought I'd point that up while you were typing.
Okay, so the debugger has some very interesting capabilities when it comes to invoking different methods. Now, if I hit F5, okay, you see we've broken out into main. Any guesses on what's going to happen when I hit F10? No, he does not get a cookie. At least the program's not going to give him a cookie if that was a... Got some jumps to 17. Remember, I said F10. Watch what happens when I hit F10. F10 is the step over, meaning it's not going to enter any other method. It'll stay in the current method. Okay, now, so that's the first consideration when working with methods. The other key, F11, is called the step into. So if I go ahead and hit F11, what we get is we have now stepped into this method. In addition, you'll see something interesting happen on our call stack window. Our call stack is the current level of methods, the hierarchy of methods that we've invoked up until this point. So if I continuously hit F11 and jump all the way down into method 3, you'll see that the call stack is this deep. So when debugging methods, the call stack is your friend. You can double click on any of the items in the call stack to jump to that method. In addition, when you do jump to another method in the call stack, you can introspect all of the variables that that method contains. So you see how we have this little hierarchy. We have the top level, which is main, followed by method 1, followed by method 2, followed by method 3. How do you reopen the call stack window? Can't find it in the menu. Very good question. You must be in debug mode, first of all. And if you are in debug mode, the window is going to be located under the debug menu, Windows, call stack. So if I were to close my call stack window, I could just go debug, Windows, call stack, and it appears. Okay, so now if I continuously hit F11, we'll notice something interesting with our call stack. Our call stack is now unwinding. It gets smaller and smaller and smaller until we're just on main again. So is there anything else about the debugger that people have questions about, at least up until this point?
Without getting...
This is just basic debug.
Right.
Yeah, basic debug usage. There is a debug class, actually, that might go... I mean, there's useful information in that recorded class, but it's not stuff that I would want to put into a
not
beginner.
a 101 class. And I know we just...
Darth Greg is correct, Segfold.
And I know that we just broke over the 3-hour mark of actual recorded content, so we'll need to be wrapping this up here in just a minute. I'll make sure to get an open office hours scheduled, if not tonight, tomorrow, and I'll get it posted on when it'll be.
You haven't mentioned homework.
Yeah, that's the last thing.
Oh, okay. Sorry, I thought you meant wrap up.
No, we're just making sure no questions.
Yeah, I'm with you.
Come in about this, and then we'll go ahead and do the homework. All right. Well, Nelson, you want to go ahead and start talking about homework?
Yes. So the homework is going to be write a basic product inventory system that allows the user to enter product names and product prices and save that data to a file. Program will load that data again if the file exists.
Hang in there now.
Write it on a normal line and then copy it across.
When it starts, program will allow the user to enter new products, remove existing products, and display current products. Program will use enums to track state and should use different methods correctly to keep individual methods line count down. Do people understand the prompt, or is there anything more that I could explain with it? Well, as far as using methods correctly, I don't know how far I should specify that. I mean, Jason and Gavin, you're free to make suggestions about how I should specify that. I don't want to give away too much.
Well, I would just say just expand slightly on what you mean by keep individual method line count down.
Well, yeah, we want to make sure that the
Save yourself some typing.
Yeah.
Essentially.
Keep methods down. No method should be larger than one screen of code. Darth Greg, at what resolution? How about maximum resolution is 12 or 1920 by 1080? Or what's your resolution, Gavin?
1920 by 1080.
Yep, that's the maximum resolution.
Well, yeah.
Whole dollars or cents? I could be.
We covered
really...
string formatting.
You what?
We did cover string formatting.
Yeah, I mean, product prices allow for decimals or cents.
Shouldn't be difficult at all. Just plan it out before you sit down and just start coding.
Yeah, after last week's homework, I figured we should throw in something a little bit more complicated.
Yeah, give them a little, opportunity to think, apply themselves.
Change up on them.
I think we're about to go ahead and wrap this up, though, and then we'll get the video encoding for everyone. And we will be doing an open office hours this week. I'll get that time figured out and post it as soon as possible. And don't forget, Thursday during the day, 3 o'clock our time, we'll be doing the UDK introduction class. Thursday night, we will be doing the next C# class. You guys are all welcome to join in if that is something that you may find helpful after tonight. And other than that, I'll get this video up as soon as I can, and you guys can review this as well. And done, we're still discussing things like exams and stuff like that, so we'll have those details soon. And I'll keep an eye on the bike, guys. Don't worry. But with that, let's go ahead and wrap this up, and we will see you guys, well, back here in a couple of days for sure. Roland, no news on C++ yet. All right, so thanks, everyone. It was a great class, and we'll see you guys all soon. Bye, everyone.
Goodbye.